Good morning, good morning, good afternoon, or good night, ladies, gentlemen, and everything in between. I am playing Shenzen IO today. This is a game about engineering, and it's gonna piss me the fur off because in the start of this game, it says you need this PDF file. So I just pressed like the datasheets PDF file. This is it. It's 47 pages long. Don't ask me why. It's a video game. But let's read it. For the best Shenzhen IO experience, we highly recommend printing this manual and assembling a binder that you can refer to as you play. Oh no. Okay, so I am going to attempt to get into this. Arithmetic? Oh my god, I don't even know how to pronounce it, let alone... Okay, cool, whatever. Okay, you know what? I'm just gonna start level 1 and I'll try to have... I'll have this handy to check what's going on. Control panel. Never mind. Can't even speak. Security camera fake. This product is an imitation mock security camera. It has two blinking lights. The first light blinks in a regular pattern. The second light is an internet light, so it should be blinking in a more random, intermittent pattern to resemble data upload. As you will notice, the design is partially complete already. A previous engineer quit before finishing the assignment. Note the timing diagrams in the verification tab. When you simulate, your output should match those expected values as indicated. Let the simulation run until it has passed all the test cases to make sure we have a proper solution. I am absolutely certain you'll do better than the last person. Don't be like the non-manual using person who quit just before you started and whose name shall never be uttered again. Carl. Oh no, his name is Carl. Okay, I thought, okay, cool. Well, there we go. I have to say, this looked... Hashtag why is this so hard? This looked way more intimidating the first time I started it up, just because I had like a quick glance at the manual, which explained this whole part already. Because this, what we have here is basically like this, just the other way around. Do that. This part is like up here. This music is hella loud. Okay, 4 lines of code. Move, P, sleep, move, 100, P0, sleep, 6. So it wants to move for some reason, but then it needs to sleep for 6 so it can move to the next time unit. Okay, that makes sense. And this is the network. That looks cool, but I probably don't want to do that. So what is this then? Isn't this an X bus? Is that what we read like 2 seconds ago? I'm gonna have to refer to this manual so many times. On for 3, off for 3. So why? Because this is what I don't get. The following program generates a square wave on simple IO pin B1 that is on 100 for 3 time units. But why? How do you know it's 3 time units? That's the thing. Because on is 100, off is 0. That makes sense. And 3 time units makes sense in this case where it says sleep for 3 time units. But the B... Oh, wait, hold up. I'll just check. Give me 2 seconds. So this basically means simple input 1 is off, sleep for 6 units, then it's on for 6 units. Isn't that just like the other way around? Or am I being like a complete doofus? Move 100 P0. How is that a... Oh. That is why. Sleep for... Wait, what was the... What did you need me to do again? Active simple output. This is weird. This actually makes sense. Okay, so what we want, I am pointing at my screen, which you cannot see. We want this simple output to be down here. So he was right. We do want it off. Reset. Wait, can I stop doing this? I can. Okay. So I may have been screwing with this for absolutely no reason. Because I think this might be good. As you can see, it's off for 6. So I guess it kind of like works differently than I thought. I thought this was going to move for however much time period you told it to move, and then it was going to sleep for 6. But it's going to do this 6 times before it moves on to the next one. So this is basically a for each loop if you're familiar with coding. And then ticks over, it gives it its new command, and then it's going to do that 6 times, which means It's gonna go up here for 6 times. It's gonna go up again, which means it's gonna do that again. Okay, well, I didn't change shit, but at least I understand what it's doing now. So now the next question is how to make this network. I feel like this is not as hard as I'm making it out to be. I'm gonna connect it. I feel like I need more information on the, oh my god, the code. Because this is still a pattern. It's doing 1, 2, 3, wait, 1, 2, 3, 4. So move, nope, 100 P0. And then we go up to 1, 2. Sleep 2, and then move for 1, 0. Keep forgetting. Nope, P0. Wait, no, I'm being a jackass. I need to do this one first. 1, 2, 3, 4. So this has got to be 4. Then move. Oh my god. 0, 100, and then we're gonna do that for sleep 2 times. Then we're gonna move, turn it off again for 1. Then we're gonna wait, and then it can reset, I think. Okay, pay attention to the network simple output. This is the network. I have outputted that into, wait. Yeah, no, that's fine. Into the same one as before, which is the P0 slot. Then I turned it off for 4 ticks. Then I turned it on for 2 ticks. Then I turned it off for 1 tick, which is basically hard coding these values. But I feel like I saw the pattern, so I could just do that, which means these are the 4 ticks. 1, 2, 3, 4. It's off. Now it's going to turn it on for 2, which is this one. Then it's going to turn it off again for 1, and then it's this. And then I'm probably going to have to turn it on again for 1. Yes, I did it wrong. Well, I didn't do it wrong. I just didn't complete it. Move on 100P0 SLP1. And then it's going to do the same thing again. So 1, 2, 3, 4. There we go. Then it's going up 1, 1, 2. It's going down 1. And it's going up 1. And then it's going to do the whole thing again. And there we go. Now we have the correct line going. This is so fucking cool. I know this is like basically the first lesson in programming 101, but... And then if we simulate it, then you can check this. The active one is the red one, and the network is this one. So every time it spikes, like this one, this, and this, these lights are gonna come on. And again, the red one comes on when this is up, and this one is for the blue one. So I'm gonna press simulate. There we go. I did it, boys! Nice. Cool. Return to mail. Thanks for your prompt work on the blinking lights. Looks okay. I feel so good. Replacement factory model. Our factory floor has some examples of older equipment that required control signals to be amplified. We had a device to adjust signals for this type of machine, but recently it was broken. Smashed. Okay then. One engineer just did not fucking care anymore. It's like... This is an appropriate project to teach you about inputs. Gee, smashed. Hang on a second. What happened? Is everyone okay? No need to worry. Okay, so what do we have? Control in, control out. Control in is a simple input connected to a factory equipment. Control out is a simple output connected to the other factory equipment. The signal from control in should be multiplied by 2 and copied to control out. Wait, what? The signal from control should be multiplied by 2 and copied to control out. So that is not that hard then. You do this, you do that, you do... Oh god, wait, hold up. I am going to need to do this again. Example circuit, ACC 0, type P. I am very confused. Following the hashtag symbol is ignored until the end of the line. Comments improve developer productivity by allowing this behavior of code to be described in line with the program itself. I start talking weird whenever I'm reading. But yeah, we used to do that back when I was a software developer as well. But we used to do this because I used to develop in C#. What I am looking for currently is how to take inputs, register. Each type of instruction requires a fixed number of operands. If an instruction has an associated operand, they must appear following the instruction name separated by spaces. For the benefit of development productivity, the MC quadruple X programming system does not require the use of redundant punctuation to separate instruction operands. Registers can store integer values between -999 and 999 inclusive. If an arithmetic... How do I pronounce this? Hold on.
Arithmetic.
Okay, so it is arithmetic. If an arithmetic operation would produce a result outside this range, the closest allowed value is stored instead. For example, if ACC contains the value of 800 and the instruction add the value of the first operand to the value to the ACC register and store the result in the ACC register. Okay, so that is what I want. Add r/i, or is that just add ACC? So that basically means that whatever comes in is going to be stored in here. Problem for me though is, can I move this? I can, because I am going to need 2 of these. Am I wrong, or pin type mismatch? Wait, what? Oh, well, this is going out to this, so this is not going to work then. Okay, so add ACC. Then whatever comes in. Oh god, wait, hold up. I'm currently reading this, which makes me believe that I want to do this, because it adds whatever comes in to my ACC register. The problem with that is, if I want to multiply it by using mul, it means multiply the value of the first operand by the value of the ACC register and store the result in the ACC register. Wait, I have an idea. I don't know if it's gonna work. Move. Copy the value of the first operand into the second operand. Ah, okay. So that is why it... Oh, okay. So sleep for the number of units specified by the operand. Okay. But that does mean that maybe if I can get an operand, which I should probably... look for the translation. Operands, item on either side of an operator in a formula. In Excel, operands can be values, cell references, names, labels, and functions. Okay. Could I do this then? Mul ACC, or is it mul 2? Because this gets 25. It's gonna add it in this. It's not gonna add it in this? Why is it not gonna add it in that? Oh! I forgot to do the sleep command. Okay, so the in is always gonna be correct, because that's the starting point from here. So this, basically what this is telling me is that this is working. It's coming in here, and that is basically... Oh my god, I forgot to do this. Add to see... Wait, yes, because I want... Wait, why is that not working? Because I want to add this value to this. And this value comes in on the P0. Too many operands. Can I just do PO then? Hey, it added. So, okay, you want to add this part to this. Multiply it by 2, which makes it 50. Okay, cool. So I have the correct value. Now I just need to output the value into the control out button. Thing. It comes in, it adds, it multiplies, and sleeps for 1 unit. Wait, shouldn't I do this then? Mov P1, stop. Mov P1, sleep 1. That is an unexpected register, which is weird to me. What if I do this? Can I do this? Because then I will copy whatever is on this to this, which basically means put this on this, which would go to control out. So what I want to see is 25. It's going to add it to the ACC now. It added to the ACC. It's going to multiply by 2, which is going to put that to 50. Which now it should copy this to that. Which it looks like it does. Yes, 25 in, 50 out. There we go. Step. And this is now twice as high as this one. And if I go through this again... Oh, I should probably clean the ACC before attempting anything else. Okay, but I mean, that's the last step. After that, it should function. Okay, I'm gonna pull up this PDF file again. Here we have the DST. Set the digit of ACC specified by the first operand to the value of the second operand. So if I go DST ACC 0, right? Because that basically means this command puts the ACC to 0. And that is after I copied its value to this. So after I've outputted it, basically set it back to 0 and repeat the whole cycle. 25 comes in, multiply by 2, move it to the, move it to the output. There we go. Reset the ACC. It did not reset the ACC. And sleep, so do it again. Fuck. Can't I just do this? Multiply by 0? Because that basically is gonna set it to 0 anyway. That worked, oh my god. And now it should be 0 still. Yes. As you can see, I have built it. Whatever comes in has been outputted double. So I'm gonna reset and simulate it. It works, doesn't it? Why do we keep doing this? Oh, you need to do it 3 times and then it works. Return to email. Looks good, thank you. Take care, yeah? Please enjoy a game. My daughter is learning programming. She created a simple card game. Would anyone like to try it and give some feedback to her? I put a link on everyone's desktop. She is interesting to become a game developer. G. Wow, Jay, that is both a lot more polished and far harder than I was expecting. Your daughter's managed to design quite the challenging patience game. Maybe there could be an undo function. She says she doesn't think it needs undo because it's actually quite easy once you develop some skill. She really takes after you. Oh, God. Win a game of solitaire. I don't like solitaire. I don't want to do that. Pulse generator. In order to test some of our new manufacturing equipment, we need a pulse generator with certain requirement specifications. Thank you. However, instead of buying one at the market price, I thought we could simply create our own. G. For this project, you will need to make use of conditional execution. Please continue your study of the language reference. I appreciate the tip. Let's see what we're doing. Oh no! I have 4 parts. Oh wait, actually no, I have a note, which is basically a note, a bridge, which... Fuck, I have no idea what that does. This one only has an extra thing, because this one, the one we've worked with so far, has an ACC estate and power level. This one is ACC that state and power. Okay, so that is new, which again, I have no idea what I'm doing, so I'm going to consult my PDF file and see what... Wait, actually, let's calm our tits for a second and check what we have to do. Diagnostic pulse generator. Button is a simple input connected to a button. Pulse is a simple output connected to an electronic device. When the button is pushed, generate pulses as indicated in the verification tab until the button is released. So when the button is off, do nothing. When it's on, basically one tick, 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 one tick. This does not look too hard, but do not quote me on that. Here, there we go. Where is the language? Labels must appear first on a line and are followed by a colon. So basically, if I say label, repeat, and I write some code, and I say jump to repeat, it's gonna go back to that label and then read all the code underneath it until it reaches jump again. And then I can probably give jump some kind of, what are those called? Requirements to, like maybe do that 2 or 3 times, and then when it's done, skip the jump, and just go down 1. I could use this, maybe. Not. If the value in ACC is 0, store a value of 100. But all I need, because I could use not, because that basically means for 1 tick, it's going to stay on, then off, because it's going to replace ACC to 100, then to 0, then to 100, then to 0. Test if the value of the first operand is equal to this value of the second operand. So we're going to build if statements. Condition, A is equal to B. Tech. Why is it called tech? That makes no sense to me. For more information on conditional execution and the plus or minus symbol, see conditional execution page 2. Right. This is basically an if statement and is what I need, but greater than, less than, I don't need any of this. I need this one. So tech. But I still don't know how that works. If, then, else, I believe. If it's 100, which it will be if the button's pressed. No. B 0 is 100. Then we want to, what was it? Not, I think? No, not. Oh, actually it was. Let me check if that even works. God damn it, I can't even check for that now. It's getting complicated. Actually, it's not. It's still very easy. I'm just not that smart. Tech B0 is 100. Then, oh wait, add ACC 999 SPL 1. Okay, I'll just add it to ACC then. I don't care. Okay, and what if I do it the other way around, that I had it first? 100 P0. Is that gonna make any type of difference? No, it's not. Okay, so maybe if I just add 100, it's just gonna add it to the ACC regardless. But that's only gonna do it if it's 100. So 0, 0, 0. And then now it's going to spike up to 100, which for some reason, it already added the other 100. It's just gonna keep on adding, huh? What if I add the plus here? Because that's like adding the condition, right? If this is true, if I scroll down here, if we go to this, tech, test if the value of the first operand, A, which is the left one, is value to the second operand, B, and then effect on plus is enabled. So that would mean that if this is true, that outputs a plus, and if it's a plus, add 100, right? And then it repeats itself. And it's not true, so it doesn't add 100 anymore. And now it should be true. So it adds 100. Okay. Cool. So that part works then. This one goes up. This knows now that it's either if it's on or off. What it now needs to do is, except for doing this, it needs to do this and then sleep 1. So that would actually fix my problem. Oh god, no, because that all that does is switch this from 0 to 100. ACC is now 100, is now 0, is now 100. Now 0 is now 100. So this part would actually move out move. So then we add that to this, which adds it to the pulse. Wait, did I not tell you to? Oh wait, ACC B1. And this gives the output of 0 because it did not change anything, because it hasn't received anything. We do that twice more. Now we receive 100. That means that if that is the same as 100, it will now repeat the not thing command, which, if I can find it here, is if the value in ACC is 0, store a value of 100, which means ACC is currently 0. The next step, it'll be 100. Now we get the ACC, we move it to the P1, which is the output, and it'll pulse, which will put this value to 100, we'll turn it on. There we go. It now resets, it checks again, do we get 100? The button is still pressed, so yes, we get 100. It means it's gonna change from 100 to 0 because if the otherwise, store a value of 0, and it is 100, so we change. We give the ACC to the P1 factor, which will throw it to the pulse factor, which means this will now turn off. Yes, P1 now has a value of 0, which means the pulse is off. And if I keep repeating that, you can see it'll do this until the button is no longer being pressed, after which it'll turn off. After which, for a longer period of time of not being pressed, the not function will not receive, the tech function will not receive any input, which means it won't even activate the not sequence, but will keep outputting whatever is in the ACC to P1, which will at all times be 0. Jesus, that was more complicated than I thought it would be. If I simulate it now, you will see that it works, I believe. There we go. Actually, I ruined it. Oh, okay. So I know what went wrong. What I currently keep doing is I just keep switching from 0 to 100. But that would require it to be held for 1, 2, 3, 4, 5, 6, an even amount of time, so that it has enough time to complete a loop, because a loop is 2 ticks long. Because this turns on, it turns off. it turns on and off again, on and off again. But what if, in this case, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, which means it'll turn on, off, on, but it won't turn off again, because for that, they would need to hold the button for 12 cycles. So, fuck, I have no idea how I'm gonna counteract that. Because that would mean that whenever it's not being held anymore, the button will stay on, which the second they start holding it again will repeat the cycle, but now inverted, because it's starting at a high point instead of a low point as we want it to, because obviously when you don't press the button, you want the light to turn off. So this is gonna take me some time to figure out what the hell I'm doing. Too bad though, because this part ran flawlessly. I thought I had it in the bag as well. God, okay. Wait, it's very easy. It might be as simple as this. Because what it does now is, as long as it's getting 100, it'll keep switching this. If it's no longer getting 100, it'll just multiply whatever is in here by 0, which anything times 0 is still 0, and then it'll paste the value. So it'll keep doing not, and as long as it's on, so it'll keep repeating, which means starting from a low point, going up, and doing hold this. But now, when it enters in like a odd, but where we were stuck like 2 seconds ago, when it enters in like at the top, because the last cycle was odd, it means it'll reset itself to 0 and then start the cycle again from scratch, if I'm right. So I'm just gonna simulate it. There we go, there we go, there we go. This one's the one we fucked up on, and we're good. I fixed, that was quite easy. I thought I was gonna be stuck on that for ages, but I fixed it quite fast. There we go. I feel really smart doing this. Return to email. Yes, looks okay. Suitable for our purpose. You're welcome, G. I'm glad I came back to this game. It's very fun. Light up signs. It begins. I got us an incredible deal with a major esports personality, the Solid Steel Gamer. Her team's contracted with us to make light up signs that actually animate for her fans. As long as we can keep the cost down, they're going to want tons of these to hand out at matches. Looks simple, just a few states. Oh no. Chip tips. Drag with the middle mouse button or the left mouse button while holding the Alt key to look at different parts of your design. Yes, thank you. I figured that out. That's with most things. Click and click 1 are simple outputs connected to display segments corresponding to a clicking animation. Drink 0, drink 1, and drink 2 are simple outputs connected to display segments corresponding to a drinking animation. Control the display segments with fixed repeating signals as indicated in the verification tab. So we basically want drink 1, drink 0 to go first, drink 1 to go after, drink 2 to go after to create an animation, then put a for each loop in to go 1, 2, 3. I think that makes the most sense to me. In my head, that's the most logical thing to do. Okay, so this is the thing. I love that I can see what like the finished product is gonna do, and that I can have this to match my outputs too, because everything's an output. How does that work? There's no input. Oh wait, I can, oh my god, that is great. Yes! Stop, thank you. Actually, creating this can't be that hard, because what I'm basically doing is add 100 not SLP1, and that goes into, oh Jesus, into click. Oh, I forgot to do the thing again. ACCP1. Step. Wait, what? I have created the first loop. That's not that hard. That was quite doable. Click 1 is basically inverted. So that means... Oh god, what does that mean? Do you think it matters how we build it? Wait, no, because that's only gonna work once. Wait, I cannot do that easily. I thought I was gonna just jinx the system, get this output, put it in here, get this to go in there, reverse this signal, take it out, yank it into click 1, then I'd be golden. But I might have a problem. I'm gonna need 2 for this, right? There's no fucking way I'm gonna do this with 1. I am not smart enough for this, dude. Drink output. As long as this... Wait. As long as this is off. Check if this is on. Wait. Check if this is off. If it is, turn on this. I can hard code this because it's the same thing every time. I think. Because it's 2 outer rings, outer rings, outer... I can hard code that. I may have found out what to do with this one. This one requires a lot of if stuff. But I kind of want this. Wait, I can do the if. No, I cannot. Can I turn this? Boop, 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 boop. Now, the problem is that I have absolutely no space for this. I don't even have to. I can hard code this. Like, absolutely hard code this. 2, 3, 4, 5, 6. Mov 6. Oh, wait. Mov 0p1. SLP1. Mov 100. SLP4. Actually, I don't want this one. I want this 6. 0p1. For how long? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Okay, which is, if I'm right, is just gonna give me all the, oh god. Drink 2 went wrong because it went on for 1 too short. So instead of, I'm gonna need you to be 7. And then it just didn't turn off. How about that? I completely forgot to do that. And now if I advance, you can see all my lines are correct. God damn it. Okay, so what is basically happening is when you see this click 0, simple output is the same as this one. It even has the same name. Now, we drag our output from this into this. So this basically controls whatever happens in here. Now, move, we know that that means of the first variable, I should say, to the second one. The first variable is 100. It moves to P1. So we take 100. Could take this value, keep switching it and take this value, but that is, in this case, not very... it's not needed. I take 100, put it in here, shoot it through for one time. Then I move on to this. I set it to 0, and then I do. It basically means on, off, 100, 0, 100, 0, 100, 0, 100, 0. Then I go to click 1, which is this one, which goes here, which means that this controls this. I do this exact same thing, but the opposite. So I set it to 0 for 1, then to 100 for 1. So 0, 100, 0, 100, 0, 100. Going up and going down and up instead of up and down. There you go. See? Move 100. It's gonna set it to the top here, and to move 0, it's gonna set it to 0 on here. There we go. And then they're gonna do it the opposite, 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 opposite. Okay, cool. Then we go to the drink ones, which are these ones. Drink. First of all, it goes on for 6. 1, 2, 3, 4, 5, 6. Then it goes on for 4. On for 6, off for 4, on for 6. And then when we simulate it, as you see, it works. Except for the fact where this doesn't. Wait, why is it hard to do? It just 1, 2, 3, 4, 5, 6, 7. Turn on for 2. 1, 2, 3, 4, 5, 6, 7, 8. Turn on for 2. 1, 2, 3, 4, 5, 6, 7, 8. Turn on for 2. 1, 2, 3, 4, 5, 6, 7, 8. Turn on for 2. Okay, I'm gonna need to check how the label works. Oh! This is already the name. So I do... Oh, wait, crap, I can't... Maybe if I remove this and do jump loop and I put loop there, it goes to 0, it's off for 7. Now it jumps into the loop. It goes 100 for 2. Then it goes off for 8. Now it jumps loop and it goes up again. Oh my god. Oh, Jesus, I fixed it. Okay, nice. There we go. Our thing works. Oh, my Jesus, that gave me a headache. I need to be done for the day. Cool. All right. So, well, I hope y'all enjoyed this episode. I will definitely be coming back to this game. But yeah, it's a good introduction to programming and engineering in general. I struggled with this way longer than I should have. But yeah, if y'all are aching for a part 2, let me know, and we'll see how that turns out. But for now, I am done. So leave a like, subscribe. You know the drill. Every YouTuber says this. Peace.